So I'm the project coordinator of MSO4SC, and I wanted to tell you a few words about the project in order to let you understand the purpose and the things we want to do. So first of all, some words about maths and computation. I was attending last week an important event related to HPC in Barcelona. It was the European HPC Summit Week, and there was some session related to mathematics and the HPC world, mainly, in which ETP4HPC, which is the main platform for HPC research in Europe, was telling about the ideas of the next research agenda, in which they wanted to incorporate somehow mathematics. And they were talking about several topics in which mathematics could help. For example, they were talking about extreme scalability, how to scale with data analytics, how to improve data placement and movement. And basically, what they had in mind is how to use mathematics in order to improve the things that we need to do in computation, scheduling algorithms, these kind of things. But here the question would be, and what about the things that the computation world can do for the mathematics world? This is one of the things that we are trying to answer from MSO4SC. We see that there are several things that in which we could support the mathematical people, such as research on new numerical methods, support more efficient execution of the software that you are doing from the mathematics point of view, and also to understand the kind of resources you may need. Also supporting co-design with the computation people. Also, we know that benchmarks are important for you, so you want to compare different mathematical methods for solving the same problem, these kind of things. And MSO4SC can support in order to solve some of these questions. Basically, what we had in mind when we started MSO, or when we were thinking about the MSO4SC proposal, was that it was necessary to facilitate the way in which modeling, simulation and optimization applications are deployed, are developed, are designed, and of course in which they are run. On the other hand, we were aware that of course you have HPC, but also now it's possible to get access to cloud resources which are rather efficient. Not as much as HPC, but still it can be exploited. Also we wanted to understand how we can support the execution management of the applications which are based on some mathematical frameworks. And here is where MSO4SC comes up, and basically what we wanted to do is to bring together three main pillars. One of them was the computation part with HPC and cloud infrastructures. Then we were bringing math application development frameworks, in which mathematics are the central topic of this software. And then we needed to validate and demonstrate the things that were possible to be done with some pilot applications using the mathematical frameworks. And in this case, very related to the current scientific challenges. So basically, what the main objective we have with MSO4SC is, as you can read there, to design, build, test, and deliver an infrastructure for hosting this advanced mathematical software, and to support all these applications using them by using HPC and cloud computing. So yes, in order to provide a very high-level view of the different layers we identified in MSO4SC, we have on one side the hardware layer. Let's say we have cloud, we have HPC. In the case of no, this one. Okay. In the case of cloud, we have the typical providers, because cloud is always more commercial. You have Amazon, you have Microsoft Azure. While on the other hand, you have more academic world related to HPC with some infrastructures such as press, you have EGI, people who are providing really efficient resources, but still it's not so easy to access to these infrastructures. So somehow we wanted to be able to use both of them, extract the best thing of both of them, and for doing so we included some layer on top of that in which we will provide some orchestration algorithm which enables the possibility to really use both HPC and cloud, especially for applications which are modular enough. So we assume that some parts, of course, require HPC because of the efficiency and the network latency, these kind of things. But still there are other parts that can be run on cloud efficiently enough. And this orchestration would merge both of them. On the other hand, we also needed some monitoring in order to retrieve what's going on with applications, what's going on with the infrastructure as well, in order to solve issues if necessary. And then we have what we call the application development layer, in which we have the mathematical frameworks. Of course, we have in this project 3 of them, which is Phoenix, Field++, and OPM. And also, we wanted to provide some MSO portal in which any stakeholder would be able to find all the tools they need. For example, pre- and post-processing tools, easy to integrate with their applications, a marketplace for publishing the things they were doing, or just to take something which is already published there for being used. Also visualization tools, these kind of things. And then the last layer would be the one of the end-user applications, in which we have some applications which are using the tools we provide. They are using the mathematical frameworks we provide, and of course, in a transparent way, they are using all the infrastructure. So basically, in the end, what we want to do is to provide some services to the scientific, to the scientists in different domains. Basically, we have 3 main parts. One of them is the one related to HPC and cloud infrastructure, with this orchestration algorithm I was mentioning before, with this infrastructure monitoring and also the applications monitoring, in which we are working this month as well, and on provision this part of the HPC and cloud resources, facilitating the access to these technologies. On the other hand, we have the part of the MSO portal, in which, as I mentioned, we will have several services and tools available for stakeholders, software and data management tools, the marketplace visualization pre- and post-processing, also some softwares for facilitating simulations management. Then from the mathematical perspective, as I mentioned before, we'll provide some versions ready to be used of Phoenix, Field++, and OPM, customized to the infrastructure we're providing, and with very nice packaging, so it will be very easy to use them. And finally, we will also provide the possibility to use the pilot applications that we have in the project. We have the list there, mainly as 3D urban quality, air quality prediction, I2Brain, Happy Magnet, Sieve Affinity, OpenFlow. So these are all the things that we expect to provide to all of you and to any people from the scientific world, in order to facilitate the access to the mathematics-based technology, enabling math as a service model from the infrastructure. And that's basically all. Thank you.